Welcome to May's Leetcode Challenge. Happy Memorial Day. Today's problem is uncrossed lines. We're given integers a and b, or rather a list of integers a and b, on two separate horizontal lines. We want to draw connecting lines between these two such that a of I equals b of j. If we're given two lists like this, 1, 4, 2, 1, 2, 4, we can see that there are three lines between the two, but it's only going to be a maximum of two non-intersecting lines. Because if we added the 2 and 2 here, those are intersecting, so we can only count one between the two. Okay, so how would we go about solving this? Well, let's first think about how we know that there's a line. And we know there's a line between 2 points when they're equal to one another. So we should iterate through this entire two lists to get whether there's a line or not between each pair. So between indexes 0, 1 and 0, 0, 0, 0, 1, 0, 2, here with 1, 0, 1, 1, and so on and so forth. We can create like a dynamic programming array to track this. So a couple questions as we go down this list. I'll try to draw it out as we go along. Let's say we're giving 1, 4, 2 and 1, 2, 4, and we have a dynamic array here with these two columns and rows representing like an empty index. So say we start here and we want to figure out, okay, is there a line? And there is, right? Because 1 and 1 equal one another. So at the very least, there's going to be one line. But because this is a dynamic programming array, we want to count how many uncrossed lines have we calculated so far. In order to do that, I'll show you as we move along. Like, let's move on to point a of 2 and b of 1. So right here, are they equal to one another? No, so there's no line. But we want to bring along how many non-intersecting lines have there been so far. So at 4 to 1, like we want to see, okay, how many intersecting lines were there at 1 to 1, and also yeah, so we're looking for 4 to 1 right here, so these two lines, and we want to figure out how many lines have we calculated so far for this point, as well as not just that, it's going to be -1 here, so as well as from here to like not counting this one. So whatever the maximum amount of lines that we've calculated there, that's what the thing we want to bring along. So in this dynamic array, it would simply be the one that's above and the one that's to its left. So the maximum between these two is 1, so we'll bring along 1. Same here. These don't equal one another, so we'll just calculate 1 there. Now what about at this point, 2 to 1? Well, we see that they're not equal to one another, but from this point, when we take out 2, we see that there was a line, right? So we've calculated that up here already. So we can just bring that along, take the max between these two, and it's going to be a 1. Now, what about 2 to 4? That's also still not equal to another, so same thing, bring the maximum between these two. But here, what about at 2 to 2? They are aligned. So we're going to have to add at least one line between the two. But what do we add that to, right? Well, if we think about it, if we want to find the maximum number of non-intersecting lines, we've already calculated that between 1 and 4. Because 2 and 2 right here, that's going to be 2 extra indexes that we add. Whatever the maximum number of non-intersecting lines we've calculated here, that we just add 1. Because whatever that is, we just add one line. At most, we can add one more. So it's going to be 1 plus the -1 of the row and -1 of the column. So diagonally to its top left, that's the value we want to bring over and add 1 to. So now it's 2. So same thing just continues here. It's going to be like 1. Here at 4 and 4, these will equal another. So we take the point here and we add that. So that's 2. And finally at 4 and 2, they don't equal another. So we just bring over the max between these two. So that's going to be a 2. And I believe that was the answer for this. All right, so let's start coding this out. It's, these sort of dynamic problems take a while to get used to. I haven't gotten the like full hang of it either yet, so don't feel bad if it's hard to follow. First, let's calculate the lengths of A and B, and we're going to create this dynamic programming array, right? So how will we do that? Well, we want to have a nested for loop, so we'll have a list, and we're going to have a list inside of that, and inside of each row, what do we want? We want the number of A's, so that's 4 n in range of n, and we want to add 1 to that, right? Because we want to have our empty index 1, and we'll just have them all as zeros, and we want to do this for each column B, so for m in range of m plus 1. So I'm pretty sure that should work. Now that we have this array, it's going to be all zeros, but luckily we don't need to calculate the first row or the first column, right? So we're just going to iterate through this DP array in its order, so we can just continue again, say for n in range, and we're going to start at 1, and we're going to go to the n plus 1, right? Because we've added an extra one. Same here for m. For m in, oh, yeah, so I'm sorry, I mixed that up. It's going to be m here and m plus 1 here for m in range of n plus 1. So many typos. And we're going to check, are they equal to one another? And we can do that because we have our list. Say if a of n equals b of m, we're going to add to our DP array point row column, and we'll make that equal to 1 plus the diagonal up left point, right? So it's -1, -1. Otherwise, they're not equal to one another. We just want to bring over the maximum between the top and the right. So that's just going to be something like equals the max of its leftmost one and its topmost one. So -1 like this. All right, so once we have that, we have our DP array. And let's just make sure that I didn't write any typos. Oh, and I definitely did. List index out of range. Huh. Oh, okay. So n and m are not correct. I have to do -1 here. So that's a little bit tricky because of this empty index that we've added to our DP array. And great, so it looks just like the thing that we typed out, right? And all we need to do is return the most bottom right number. So let's return that. We're going to return DP array of that. So let's go ahead and submit this and accept it. So this took a while for me to figure out. I still don't completely understand it, and I think with these dynamic programming problems, like, it's just practice. Like, I know that there's a recursive solution as well, but this helps out breaking them up into subproblems. I had the part that was hard for me was figuring out that we need to simply bring over the top left point. This part confused me a lot because I was trying to first bring over the max between the top and right, or the top and left. But anyway, hopefully this does work, and hopefully more reps will eventually, get you to get good at these. So yeah, let's keep practicing.